In this session, we'll see about the plot types and use cases. So the key insight behind this topic is that knowing how to draw a chart is only half the skill, but knowing which chart to draw for a given situation is another half. And it is the half that separates a good data scientist from the average ones. So in the last lecture that you might have learned the Matplotlib architecture and how to draw your very first line plot. And now we'll go wide, covering up the 10 plus different chart types, explaining the concept behind each and every chart, showing the code, and most importantly, teaching you to pick the right one for the right job. So think that this lecture will give you a visualization vocabulary, just like a writer needs more than one word to express his idea. The data scientist needs more than one chart type to communicate the data stories. So let us get started. So this decision guide is a single most important reference slide. Either you can pin it or you can screenshot it or you can memorize it. So the core idea is very simple, that every chart type exists to answer a specific type of question. So if you match the chart to a question, your visualization is well communicated clearly, right? So if you mismatch them, then your audience will be confused. So let us walk through each and every decision. So if you have to compare the categories, then you can go ahead with the bar chart. So when you want to compare the values across the distinct groups, say cities or products or countries or any programming languages, the bar chart is almost always the right answer, right? The length of each bar makes a comparison initiative. Like you can use this bar chart mainly for comparing the categories. Now let us move on to a line plot. So if you have a data that has to be tracked over a period of time, then you can use the line plot. So when data is ordered along a time axis, say a daily temperature or a monthly sales or the annual growth, a line plot shows the trend up, which can be an uptrend or a downtrend, and the rate of changes all can be plotted by using the line plot. And the histogram or a box plot. So if you have to show out the distribution, then you can move ahead with the histogram plot or a box plot. So when you want to understand how are the values spread out, you can use a histogram for a detailed shape, or you can use a box plot for a compact 5-number summary. So this histogram can be used for a single group, whereas this box plot for comparing the multiple groups. And the relationship between the two variables can be um, identified with the help of a scatter plot. So when you have, say, two numeric variables and you want to see if they are correlated, how strong the relationship is, and whether there is any outlier, you can go ahead using the scatter plot. And when do you use this pie or a stack plot is when you want to show like how the total is divided into components. You can use pie for a single snapshot, or you can use the stack plot for how composition changes over the period of time. So this is the main use of a pie or a stack plot. And then when do we move ahead with the 3D scatter plot or a surfaces? Say when your data is genuinely and it has got three numeric variables, then you can use like a 3D plot, and you can draw or read the um, values in the 3D plot. So say like you can use this 3D plots sparingly, that they are often harder to read than a 2D alternative. Then you can move ahead with a 3D scatter plot. So main thumb rule here is that before writing any code, you have to ask yourself like, uh, what question am I trying to answer? Then find out the chart type that answer the question most very clearly. So that is how you can choose the right chart for in order to make out a better decision. The line plot is one of the oldest and the most universally understood chart type. So this it is a foundation of the trend analysis. So what does it does is that a line plot will connect the data points in order, usually from the left to right or from earliest to the latest with a continuous line. So the eye naturally follows the line and perceives the overall direction, say whether it is an upward trend or whether it is an downward trend or whether there is any fluctuations here in this line, right? So when we use this is that the most common use is when you have a time series data, like any data measured or recorded over a regular interval of time, say the stock price over a month, say you have the timeline here, and for the over the month, what is the stock price, what is the temperature over a period of day, or what is the website traffic over a period of week or a population over decades. So you can use even the line chart as multiple lines. You can express a line chart with line plot with multiple lines. So you can plot several lines on the same axis. You can have um, more than one line plots here. So say for example, you wanted to visualize a line plot for the sales in 2022. Say that this is a line plot for 2022 sales. Even in the same plot, you can make out for the sales in 2023 or the revenue versus the expenses over a period of time. So you can try to manage at least drawing 4 to 5 lines of line plot here in a single graph. So this is how the line plot works. And now when we move on to the code, so let us walk through this line plot code line by line. So this is the cleanest and the most readable way to write a basic time series chart. So first, let us import the matplotlib library. As I have mentioned, import matplotlib pyplot as PLT. So wherever we have to use the matplot library, you can use PLT in short. So we are going to write down the months. So we are going to make out the months as Jan, Feb, March, April, May, and June. So this is for the x-axis data. The months have been taken as string, and the matplotlib, it places the strings value evenly spaced in the order you provide them. And sales, it has got the values, say 120, 135, 158, 142, 175, and 200. So this is going to be your y-axis data, and the units sold each month. So this list must be the same length as the month, because both should have the same 6 elements. Okay, and now let us move on to the next line. So it is plt dot plot of. So I'm going to plot for the month as well as the sales, right? So I'm going to plot for month and sales. So we have given a marker. So I think you can remember now, if the marker is O, then it places a filled circle at each data point. So here you are able to see a circle at each and every data point. So it is going to give us the filled circle, and the color code here is given as hash 065A82. So this is a color code, professional dark blue hex color, and the line width is given as 2, which will be slightly thicker than the default 1.5 line, which makes a line more readable. And now for this title, for this plot, I'm going to give the title as monthly sales of H1. So H1 means like it is for the first half. This is a main common business abbreviation that is used. And now let us give on the label for the x-axis. So plt.x label of month. Okay, so the x-axis label and the y-axis label is unit sold can be given. And once the label is given, let me define the grid. Okay, so grid alpha value is given as 0.3. So it means that the very subtle grid. So 0.3 is 30%. I wanted it to be as opaque. So just visible enough to help to trace the value, not so visible that it distracts rather in on hand. Like, and then plot dot show off will help me to display the chart, right? So this is a line of code for the a line plot. So here, the when you run this code, this is going to be your output. So let us discuss on the output. So you can see that for the Jan, the sales is 120. For the Feb, it is 135. For the March, 158. So you are able to see the trend of sales with the help of this line plot very beautifully. So this is how the line plot works. So you can try ahead with different values of sales and see how the trend varies. And next, let us see about the bar chart. So bar chart is the workhorse of data comparison. Like if someone asks you to compare the values across categories, then your first thought should almost always be that you are supposed to use a bar chart, right? So what does it does is, for each category, okay, every category gets out a rectangular bar. So the height here for vertical bars and the length for the horizontal bars represent the value. So the human eye is very much extremely good at judging the relative length, making the bar chart very accurate for comparison. So if you wanted to have a comparison of vertical versus the horizontal bars, so like plt dot bar, okay, plt dot bar of method will indicate the vertical bars, and plt dot barh, like bar of h means it is a horizontal bar, okay. So bar of is for x-axis, and for this horizontal it is for the y-axis. So you can use vertical when you have few categories with short names like A, B, C, or even Jan, Feb, or March. And you can use the horizontal when you have many categories or the long names. So this is the main use of the bar chart. And bar chart must start at 0 on the value axis. So why is because we judge that the bar chart height as proportion, and if the bar is twice as tall as the another, we perceive that the value as twice as large. So if you start at 50 instead of 0, then the value of 45 looks 5 times larger than the value of 51, right? So this is one of the most common ways the charts are used to mislead. So as a data scientist, always start your bar chart at 0. Fine. And you have different other bar charts like grouped bars or stacked bars. So grouped multiple in group you can the multiple bars can be grouped side by side for each category, like comparing the subgroups, and stacked bars stacked on the top of each other. So this is the illustration which shows you the 4 bars of different height, a simple comparison for a 4 category, that is A, B, C, and D. So now let us analyze this bar chart code carefully, and this is one of the very important technique here you will which you will be using very constantly. Like first importing the matplotlib library, matplotlib.py plot as plt, and now let us have the list as language. So languages are given as Python, JavaScript, Java, C++, and Go. So this is the x-axis category, the programming language, where these are called as strings. Okay, so these are strings. And next we'll have the variable called share. I have given the value like 33, 26, 17, 14, and 10. So these are y-axis value. And the percentage of developers which use each and every language. Say that Python is being used by 33% of the developers, and JavaScript is used by 26% of the developers, and Java 17, C++ by 14% of the developer, and Go by 10% of the developer. Okay, so now let us see like how to and it is mandate like it is always like you sort your bar chart data by value so that the ranking is immediately visible, and you can use this plt dot bar of, you can give the x-axis and y-axis values. I've given different colors for each and every language, so it is your interest to make out the different colors. And let us now break down like this language. X is going to be my x-axis, and the share of percentage is going to be the y-axis value. So let us give the plot title. So title is going to be Stack Overflow Survey of the top languages, and let us give out the y label. And with the plot.show method, you'll be able to get this plot. So here, when you pass a single color, like color is equal to blue, no, like rather instead of giving out different color, you all the bars will get the same color. So, but when you pass a list of colors, it looks like good, and this keeps the keeps each and every languages to be distinguished from the other. So it is up to you to change it. So you can notice here that this is how will be the output. So Python has been used by 33% of developer, and you can see here it has started from 0, right? So so you can modify this code to add up the plot.bar h of instead of the plot.bar of. So here, as I have mentioned earlier, that plot.bar of will give you like the horizontal axis value. Okay, and here you can just change out for bar h of, and see how does your chart look like. Next is a scatter plot. So scatter plot is your primary tool for exploring the relationship between the two numerical variables. So what it does is say that every observation, that is the data point. So every row in your data set, say that you have got a data set here, and every row in your data set here will indicate a data point. Okay, so every row will indicate the data point, so it becomes one dot. Okay, so this is one observation. So here the dot's horizontal position represents the one variable value, and the vertical position represents another variable value. So the overall pattern of these dots reveal what is the relationship between x and y. Say, consider that we are going to take out this dot. So this has got a corresponding x-axis value, and this has got a corresponding y-axis value, right? So what is the relationship between the x-axis and the y-axis? The overall pattern can be identified with the help of the scatter plot. So there are different types of correlation pattern. First is the positive correlation. So say that if when do you call as a positive correlation is the dots which form a cloud, okay, going from bottom left, okay, so this is your bottom left to your top right. Okay, so when you have a pattern like this, so if this, you can call it as positive correlation. So when the x increases, your y also increases. Okay, so this is about the positive correlation. So say that an example, the number of hours that the students study, okay, versus the exam score. Okay, so it is going to give me a positive correlation, right? So as the student studies, keep on studying, and the hours get increased, he is going to obviously score a good mark. So this is a positive correlation. Whereas for a negative correlation, so here you can see that you will have dots like this arranging from the top left to the bottom right. Okay, so you will have points over here. So when you have data points like this from top left to the bottom right, then you call it as the negative correlation. So as the x increases, okay, so the y will tend to decrease. Okay, say an example that I can demonstrate for negative correlation is the price versus demand. So as the price increases, the demand is going to decrease, right? So this is an example for a negative correlation. And what about the no correlation? Is the dots will be scattered out randomly. So you will have the dots to be scattered all across the entire plot. So when you have such a sort of scenario, then you can call it as the no correlation, because x and y they entirely they are unrelated to each other. So this is about the different correlation pattern in the scatter plot. So you can even encode more information from each and every dot beyond the x and y positions. And when you have 1,000 of data points, or dots overlapping each other, and the chart becomes like a very solid blob, then you can find out another solution, like using out the alpha, or using out hex bin, which divides the plot into hexagonal bins and color code the density. You can use jitter, which can add tiny random noises to spread the overlapping points. So you can use any of the overplotting techniques to overcome the issues which is caused by the scatter plot. And once this main use of the scatter plot is that often the it can be used to represent the regression line. So often paired with a trend line or regression line to show a better fit of linear relationship, you can go ahead using the scatter plot. So in CBON, there is a method called as SNS dot regression plot of, so REG plot of, which adds this automatically to be used. So this is about the scatter plot. And let us look into the code of the scatter plot. So first, let us import the scatter plot. First, the matplotlib library and the numpy as np. Okay, now let us move on. So this is the variable, rng is a variable, so I'm going to use numpy.random.default underscore rng. So I'm going to use a random number. So it is random generator. RNG is a random generator, random number generator. So this creates a random number with a seed value of 42. So why is this seed? So because the random numbers are technically like pseudo random, they follow a deterministic sequence based on the starting number. So starting number, that is the seed, right? So using seed is equal to 42 means that every time that you run this code, you will get the same random number. So this makes your results reproducible, like which is essential for the science and for collaboration. So you can use this random number generator along with the seed number. And the next is the RNG, which is a random number generator dot. I'm going to make out normal distributions of normal 0, 1, 200. So this generates 200 values from a normal distribution with a mean of 0 and a standard deviation of 1. So this simulates one measurement variable. And the next line, say y is equal to 2 into x plus random generator dot normal of 0, 0.5, 200. So this y is 2 times into plus some noise. Okay, so 2 times 2 into x, x is a noise. And this 2x part creates a strong positive correlation, like the RNG dot normal of 0, 0.5, 200. No, it adds up some random noise, making the relationship imperfect, as real world data always is imperfect with noises. So this random function will generate the data with some imperfection. So in order to make it out perfect, we go we create a strong positive correlation data with the two times of this the x value, 2x value. And now is about the scatter. How do you make out the scatter plot? So plt dot scatter off, you can give your x axis, y axis value, and what is the color that you want, and what about the alpha value. So alpha value is going to be 0.6, and so say the 60% of opacity will be provided, and here where the dots overlap, then they appear to be as darker. And yes is 40, so it is the size of each dot and points. And we have made it to be as square. The default is about 36, and the edge color is given as white. Okay, so here this separates we have given out like the thin white border around the each and every dot. So this separates the overlying dot, visually making the chart to look very polished. Okay. And next, let us give out the title for the chart and give the label for the x-axis and the y-axis. And when we print it, you can see here like it is very polished to see when the alpha value is 0.6. No, here the dots wherever it is overlapping, you can see white color overlapping it. The points are being darkened, right? So here overlapping points are darkened. So this is how the scatter plot is being made for the variables, say x and y. So here a normal distribution plot is made. You can use any function to create the scatter plot. Okay, fine. So you can try ahead moving out with different distributions. You can make out the scatter plot. And next, let us move on to the histogram. So histogram is a fundamental tool for understanding the distribution of a single numerical variable. Say, what does it does is that it takes a set of numbers, say divide the range into equal width interval, we call it as bins. And it counts how many values fall under each bin. So say that each bin has got, say this has got 5 values or 10 values, this has got 15 values. So the height of each bar is equal to the count of the values in each and every pair. Okay, so here the distribution is what that matters. So before analyzing any numerical variable, you need to understand its distribution. So whether it is a symmetric distribution or whether it is a skew distribution, or is there any multiple peaks, or does it have any outlier? So that's very important first to analyze it, right? So the distribution shapes that you can encounter might be like it is a symmetric, then you will have a bell-shaped curve. So it is a symmetric, then you'll have a bell curve, which is very similar to a normal distribution curve. Or if it is right skewed, then most of the values are low with a long tail going to the right. So example, this the income distribution, like most of the people earn an average and few earn in millions. Okay, so it's going to be right skewed. Or if it would be left skewed, then most of the values are high with the tail going towards the left. So say that the exam score in each and every EC test. Okay, so for the EC test, they might score very high, right? So it's going to be left skewed. And if it is a bimodal, then you will have two distinct peaks. Say you will have two distinct peaks like this for bimodal. Say for example, the customer ages at a store that sells like both kid toys and then adult electronics, right? So customer will have both the sort of customers will have a good sale. So all the values are like high at both the peaks, right? So it is bimodal. And if it is uniform, then all the values are roughly equal. Say a fair dice roll, right? So it's going to be an equal, right? So this is about the different types of distribution shapes that you can expect in a histogram chart, right? And next is about the bin count. Okay, so if you have got two few bins, okay, so if there is only a very little number of bins, then the histogram look like a 2 to 3 tall bars. Okay, so here we have got enough number of bins, or else it would be like one or two tall bars. So if it is too many bins, then the histogram looks mm, like a noisy spike pattern, like random variations might dominate. Okay, so just right, you can see the overall shape clearly, like here that each and every bar varies, no? So the main rule of this thumb square root of n is that square root sqrt of n. This is the starting point. Okay, say for n is equal to, there is 1000 observations, then you can try a bin of 31. Okay, so for say for n is equal to 100, then you can try a bin of 10. So this can adjust adjust the histogram visually, so that there is no one perfect number. This is how the histogram plot is being made. Now let us move on to the code. So let us walk through the histogram code, and as we have seen that, first let us include the matplotlib library as PLT, and then we can import the numpy as NP. And now let us make out the histogram chart. So for making out the histogram chart, first let us use that numpy.random. Let us make out a normal distribution points, okay, distribution curve. So generating the simulated data. So I'm going to make out simulate 1000 adult height. Okay, I'm going to make out the 1000 adult height following a normal distribution. So the mean value which I'm going to give for normal distribution is 170, and the standard deviation is 8. Okay, so let us assume that the person with a mean of 170 centimeter height and a standard deviation of 8 centimeter height. So I'm going to generate a random 1000 samples, which is large enough to see the bell curve shape very clearly. So with this random.normal distribution function, you can create this random data points. So once it is done, then you can make out the histogram chart by calling the function histof. So plot.histof, you can mention the random points. So random points is assigned to the variable called heights. Okay, so for all the 1000 random points, I have set the bin size to be as 30, and I've given the color code and the edge color as white. And once this histof function is being called, right? So the data is in an 1D array, okay, and bin is 30, which divides the range into 30 equal width intervals. Say for 1000 data points, 30 bins is a good choice. So you can choose 30 bins. Okay, so here now when we move on, we can see the code next to give out the title and to give out the label for the x-axis and the y-axis. And now when you make out run this code, when you give plot.showup, it's going to give an output like this. So what you look for in your output is that, is it symmetric? Is it a normal distribution? Yes, you have got a symmetric curve. So this is going to be a normal distribution curve. And you can find here, like, where is the peak? Yes, you have got a normal distribution, and you can find where is the peak. So this is the mode, which is the most common value, and how wide it is, the width relates to the standard deviation, like how it is spread across. Okay, and is there any outlier? Say, is there any bar which is far deviating from the main group? So here you can, this all is quite altogether. Say that you have got a bar somewhere here, okay, which is more deviating than the other, then you can consider it to be as an outlier. So this is a use of this histogram. Fine. And now let us see about the box plot. So the box plot is also called as the box and the whisker plot, which packs the five statistical summaries into one compact visualization. So this is a standard tool for comparing the distribution across multiple groups. So what is this five numbers that we have is minimum, then Q1, median, Q3 and max. This minimum will indicate the smallest non-outlier value, and Q1 is the quartile one, which is 25 percentage of the values that are covering up in this. It is Q1, and median is Q2, which will cover up 50 percentage of the value. So this is actually called as a middle value, so half above and half below. And Q3, this will cover up 75 percentage of the values below this. And maximum is the largest non-outlier value. So here you can see the box. So box, it is a rectangle which spans from Q1 to Q3, right? So this range, this you call it as the interquartile range. So say this Q1 to Q3, no? This you call it as the interquartile range, which is IQR, okay? And this contains the middle 50 percentage of your data. So this portion cover ups totally 50 percentage of your entire data. So this is the interquartile range. And this white box, no, so this the interquartile range means a high spread, and the other part, the narrow part behind the interquartile range will mean the 50 percentage of the clustered data. So here you can see that there is a mid line or the median line, say Q2, that it is, notice that it is not necessary that this median line should be in the middle of the or in the center of the box. So if the distribution is skewed, no, then the median will be closer to one edge. So you can say that the median would be somewhere here. Okay, so if it is skewed, or the median would be somewhere here. So it is based on the distribution of your data, your median will change. And then you have got the whisker. So here you are able to see that the line is extending from each side of the box, right? So the box edges. So they go out to at most 1.5 times of the interquartile range, that is beyond Q1 and beyond Q3. So the data points beyond this whiskers, you can show it as an individual dots, and that can be classified as an outlier. So if there is a data point in your data set which is falling out of the minimum value and the maximum value, then all those data points can be considered as the outlier. So why do you might have a question like why it is 1.5 into interquartile range. So this threshold was chosen by the statistician named as John Tukey, because he assumed that it correctly identifies the extreme value in the normal distribution while not flagging out too many values in the other distribution. So you can use this 1.5 into IQR to make out the box plot and to find out the outliers. Then let us make out a question like when do you use a box plot and when do you use a histogram, right? So you can use a histogram when you have one group and want to see the shape in detail, then you can go ahead with a histogram. But when you can use box plot when you have multiple groups to compare it side by side, then you can go ahead using out the box plot. Say that the box plot with 10 groups would easily fit into a single chart. So 10 histograms would need 10 separate charts, right? So this box plot hides the space, and the bimodal distribution like two peaks looks the same as a a single peaked one in a box plot. So for that reason, the violin plots are increasingly preferred more than the box plot. And let us see the box plot code. So here we can see, as if we have seen earlier, the importing the library of matplotlib.py as PLT, and we are importing the numpy library. So let us generate the random number. So random number generated with seed value as 0. And once the random points are being generated, we'll make out a normal distribution data points. So this is a list of data points which I'm creating out. So I'm using a for loop. So this creates 4 array, one for each group. So let us have 4 groups. So out of the 4 groups, so group A, it will have 100 values ranging from 0 to 1. So 0 is going to be your mean value and standard deviation as 1. Then group B as 100 values from the normal distribution. Mean value is going to be as 2 and standard deviation as 1, and then we'll have it the same for group C and group D. Okay, so the groups have got different mean. Say one group has got mean as 0, other group has 2, other group has got 1, and other group with 3. So but it has got the same spread of standard deviation to be as 1, right? So you're just changing out the mean here. So in the mean, for the LOC, for the mean, you have given 0, 2, 1, and 3. So it has got 4 different groups, right? So now let us make out the box plot for this. So PLT dot box plot of, you can give your data points and you can label the 4 groups as A, B, C, and D. Okay. And once you give out the title and the label for the y-axis, if you run this code, you're going to get an output like this. So what you observe in the output is that the group D, right? So here the mean value is 3. It should have the highest box. Yes, so this is the highest box. It means that the median line is furthest up. And here for group A, that mean is 0. Then for group B, you can see that the main is 2 here. So all the boxes should be similarly in height, like same spread with the same interquartile range. So looking for any outlier dot beyond the whisker, this so here is an outlier, and in D here is an outlier, and in B is more or less very close to the minimum value. So you have an outlier here. So this is how the box plot will help you mainly to find out the outlier. And next is about the pie chart. So here for the pie chart, this pie chart is very famous chart in the world. Like it can be used for various applications. So here you divide the circle into like slices. Okay, so where every slice angle is proportional to its share of the total. So a slice representing 25% gets a quarter of a circle, like a circle of 90 degree. Okay. So when does this pie chart work is that when you have 2 to 4 category, and the if the difference between the category is very large and obvious, and you are showing that one thing dominates over the other, say that the Python has got 50% of market share. Okay. And if your audience is non-technical and they need to infer something very immediately, what they are not familiarized with, then you can go ahead using the pie chart. Okay, so mainly for the data science community, most of the data scientists and the visualization expert, they prefer the horizontal and the bar chart over the pie chart for almost for all the use cases. Say like the bar chart allows you for the precise comparison, whereas the pie chart allows only for rough and the approximate comparison. So a famous statistician named as Edward Tufty, like he has said, like the only worst design that a pie chart is several of them. So that said that pie charts are everything in business presentations. Knowing how to make um, one well is a practical skill, right? So with percentages, with labels, with clean colors, and with few slices, you can make it more presentable. So if you find yourself choosing between a pie chart and a bar chart, and you have more than four categories or a value are similar in size, you can choose a bar chart. So it will communicate your data more accurately. And let us look onto the pie chart code. So here let us import the matplotlib library, and let us give out the labels here as rent, food, transport, savings, and other. And I'm giving out the amount. So amount is 1,200, 600, 250, 500, 350. So these are just raw values. And this will automatically convert these, the matplotlib will convert this raw values into percentage. Okay, so that's the beauty of this matplotlib too. And you can give out the color for different labels, and you can call the function called as pyoff. You can pass the variable amount and labels. You can give out the color. You can give out the different angles at which the pie chart has to look like. So you can give out the values, and once the value is given and the title of the plot is made, you can, once after you run it out, you will get the pie chart with this output. So here you can see that there is a keyword called as auto PCT. So auto PCT is given as percentage 1.1 F percentage. So this is a key parameter. So it means that it is an automatic percent. So the formal string is percentage 1.1 F. It's a formatted string which shows like one decimal place, so that you get 41.4 percentage printed inside each and every slice, right? So for rent you get 41.4, and for the other you get 12.1 percentage, right? So without this you get a chart with no numbers, and the whole point on a pie chart is to show the proportions. So you can use the starting angle to be as 90. So this is how you make out the pie chart. Template is a more specialized chart that most of you have not encountered before. So this is a digitized descendant of a hand-drawn explorative data analysis tool. So what does this stem plot does is that for each and every data point, say x comma y, it draws out a vertical line. So this you call it as stem from the baseline y is equal to 0 up to the value with a marker. This marker, you call it as a leaf at the top, right? Okay, so think of it like an integer toothpicks which stands upright on a surface, that each one has a different height. Okay, so here you can see the stem which has got a different height. So how does this stem plot differ from a bar chart is that, so both stem plot and bar chart show the integer values as a vertical extent, but the key difference is that in bar chart you have a solid filled bar which emphasizes the magnitude of the value, whereas in stem plot you have a thin line with a dot, right? So emphasizes that each value is in a integer discrete observations. And you can ask me a question like, where is this stem plot being used? So this is mainly used in the signal processing and electrical engineering. So when you have a discrete time signal, a series of values which are recorded at a specific time step, a stem plot can be used as a standard representation. And each sample, the discrete measurements, which can be shown as a separate stem, making it visually clear that these are the distinct measurement and it is not a continuous one. So it shows you a clear picture with the help of a stem plot. Now let us look into the code of drawing the stem plot. So let us import the matplotlib library, and I've given the range of values from 1 to 11. So 10 for 10 positions. So 1 to 10 is going to be the value for X variable. And Y, I'm going to give the 10 signal values. So the 10 signal values are 3, 5, 2, 7, 8, 4, 6, 9, 1, and 5. And now just a very simple call that you have to make out plt plot dot stem of method to draw the stem plot, stem of x comma y, which gives you out this one and only one line. This one function call would make out the stem plot for you. And plt dot title, we give the title of the stem plot, and plt dot show off will show you the plot. So for general data science work outside the signal processing, you will use the stem plot very rarely, but understanding them rounds out your visualization vocabulary and prepares you for the signal processing and even for a time series application. And now let us see what is meant by a stack plot. So stack plot is an evolution of a line plot, I can say, like for showing out the compositions over a period of time. So instead of asking like what is the total, you ask what are the parts that make up the total. Okay, so that's the main difference. So what it does is that like multiple series are stacked on the top of each other. Say the topmost line shows the total of all the series combined, and each colored area between the line represent the one component contribution. So here you can read from this output like this free was what is the contribution of this free, and what is the contribution of pro, and what is the contribution of the enterprise subscription. So here, how do you read the stack plot is the height of each colored area at any x position shows that the component value at that particular time. So this is the height of each colored area. You can see that in the x position. And the total height, so the top line shows the sum of all the components. So here you can see that the total height, the top line is at 100, and you can see how the composition, like proportion of each pieces changes over a period of time. So here you can see for a period of time how is the user proposition being changed. So here let us check out the example use case, like the revenue breakdown, like how much comes from free versus pro version versus enterprise users over a period of years. So this is the best example that we can give. And let us look into the code. So here X has got the year value, and I've used the three variables. One is free, pro, and enterprise variable. So I've given out the values for each and every variables for the consecutive years. And now when I call the method called stack plot of, it is going to plot for me the composition over a period of time for all the three labels as free, pro, and enterprise. And you can give the legend. So this you can note it down like plt.legend of method. I'm introducing introducing the legend here. Like you can make the legend to be at upper left or upper right or lower left or lower right. You will have a legend as if it is appearing here, and plt.showOff method will give you the chart. So this is the use of the stack plot. So the main function, the key function of the stack plot method is that it passes the x-axis value, and then each y series has a separate argument. So each series should be the same length as the x. So this is how the stack plot works. Error plots are often overlooked by the beginners, but they are critically important in the scientific and research context. So let us see like what they are. So vertical line or a horizontal line added to each data point showing the range of the uncertainty around that measurement. So here you are able to see like the horizontal line and a vertical line for each and every data point, right? So this you call it as an error bar. So why do they matter is that every measurement has got an uncertainty, right? So a thermometer is accurate to plus or minus zero point 0.5 degrees. So a survey result has a margin of error, right? And experiment has run to run variation, and without error bar the chart shows like data as if that it is perfectly precise, but which is not true. So there are three common error bar types, general, like the standard deviation, which shows the spread of the individual data point. So larger the standard deviation, more variable data. And the standard error bar, so it shows the uncertainty in the mean, and 95% of the confidence interval, which will show the range where you are 95% confidence the true mean lies. So this 95% confidence interval chart, the common error bar type is used in most of the publication. So in the scientific publications, the plots without the error bar are often rejected by the reviewers as they are considering the incomplete, it to be as incomplete because they hide the precision of the measurements. So here now let us see at the code, say for the x coordinate and the y coordinate, the points are being given. And this for the error plot, I have given 1, comma 2, comma 1.5, comma 2.5, comma 1.8, which is uncertainty at each point. So it is different for each, and now I can plot the error plot like plt dot error bar, giving out the x axis value, y axis value, and the arguments say y error. So y error is a vertical error bar size, and FMT is a format string for the marker, and here we have mentioned with the line and the circle. So O indicates a circle, and connecting line is going to be dash, and the cap size is 5, which adds a small horizontal cap at the top as well as at the bottom of each error bar. So without cap, the error bar just look like a plain vertical line. So you can give this cap over here, so they can clearly show the extent of the range as we have in even in our box plot. So so whenever being a student, like whenever you plot a mean value from the sample, you can add the error bar, so it shows you to understand the data very well. And next plot is a violin plot. So this violin plot is a modern alternative to the box plot that gives you more information about the distribution shape. Like this violin plot combines out two things. One is the box plot, and the kernel density estimate, which you call it as KDE. So this box plot, as we have seen earlier, the innermost part shows the median and the quartile, say Q1 and the Q3, which covers up the 50% of the distribution of your data. And kernel density estimate, that is KDE, which is called as the violin plot. So here the outer violin shape, like it shows the probability density where the values are very much concentrated. So the width of the violin plot will be highest at the high, at any height represents how much values are nearer that value, right? So here the wide section means that many data points are there, and the narrow section mean here that there is only a very few data points. So here in group B you can see a narrow section and a wider section. So you have got a lot of data points in this section rather than this narrow. So why this violin plot is better than a box plot is that box plot cannot distinguish between a normal distribution and a bimodal distribution. Like both look the very same in the box plot, but this violin plot shows a bimodal shape clearly. Like you would see the two bulges in the violin plot, right? So say for example that we want to compare the exam scores between the two groups. So group A, here all the students have scored between 60 and 80, and there is a narrow violin thin uniform bar. and group B, that half has scored around 40 percentage of the mark, and half scored around 90. So wide violin at both the levels. So it is going to be a bimodal. And here the box plot might show even the similar medians and IQR. This violin plot would reveal the group B's bimodal nature. So here let us move into the code. So here the data is equal to the random generator. I'm generating a random a number for the normal distribution ranging from the mean 0 and the standard deviation 1 with 200 data points. So three groups I'm going to create: A centered at the 0, centered at 0 with a spread 1, and B centered at 1 with a spread of 2, and the C which is centered at -1 with a spread of zero point 0.5. So it is going to give me a narrow violin. So this plt.violin plot will give me the plot for the data, and you can show the median to be set the show median to be as true. So this is how you make out when you give plt.showOff, your violin plot is being as if it is shown here. This is going to be our output. So when we compare the matplotlib versus the Seaborn, this is matplotlib's violin plot is a functional, and but it is limited in customization, where when you compare with the Seaborn's SNS.violin plot of which will be covered in the later modules, that it will be more polished and it is very much easier to use. And now let us see about the heat maps. So heat maps are the tools which is used for visualizing the 2D matrices. Anywhere you have your data that naturally forms a grid with a value at each and every cell. So what does this heat map does is that it takes a 2D array, say a row and a column, and the colors at each cell is based on its value. So the color scale or the color map, it maps the lower value to one color and a higher value to another color. So here you can see the heat map, the correlation heat map here. Like -1, it is of dark brown, and 1 which is of very dark blue. So this is the correlation matrix example. So when you have many numeric values, you can compute a pairwise correlation. Say you have got A, B, C, D, E, F, and G, H, and the other variables which you can map it out pairwise. So for A and A, you can see here the correlation value is 1 because it is very highly correlated. So if they are very much correlated, you will have the value closer to 1. And if there is less correlation, you will have the value closer to -1. Okay. So the cells with the correlation close to +1 will be indicated as red, and close to -1 it will be indicated with the brown. So here we can even make out the confusion matrix. So confusion matrix is mainly used in machine learning, and it shows out the predicted versus the actual classes. So this heat map makes it instantly clear like whether the model is accurate or not. And you can use this heat map generally to find out the correlation between the different variables. So if you have two features which are highly correlated to each other, say that A, B, C, D, E, F, G, and H are the features. So say that E and D, for example, if it is very closer to 1 and it is very much highly correlated, then you can, rather than having both the features, you can have any one feature. So now let us look into the code. So you can import the matplotlib library, and you can generate the random numbers ranging from 8 to 12. And once the random number is generated, you can use the IMShowOff method to show the heat map. You can give the color bar for the labels and the title for the graph. So this is how the heat map can be used to visualize a 2D matrix of Violin. So here is about the preview of the 3D visualization, which can be covered deeper in the later modules. I'll have a touch on the four 3D plot types. So we have got 3D scatter plot, then 3D line plot, surface plot, and the wireframe plot. So 3D scatter plot is just like a 2D scatter plot, but each data point has got three coordinate, say X, Y, and Z. Like it is excellent mainly for visualizing the clusters in the 3D feature space, which is very much common in the machine learning domain. And next is about the 3D line. 3D line is a trajectory or a path through a 3D space. It is used in physics, is used in simulations, robotics, for robot arm path, and for GPS tracking to track the latitude, longitude, and the altitude over a period of time. You can go ahead with the 3D line. And surface plot, it shows a smooth surface over a 2D grid of x comma y points where height c is a function of x and y, and you can use this surface plot to find out the terrain elevation map. So if for geospatial computing problem statements, you can go ahead using out the surface plot. And next is wireframe, where it is very similar to a surface plot, but rendered as a mesh of lines instead of a solid surface. So it's slightly easier to see the underlying shape rather than a surface plot. And this is a real world example which I can give you for the Netflix subscriber growth. So this is the sample code where you can see the input is going to be the year and the subscribers in millions. So you can make out the plot with the help of a line plot, and you can see like how is the trend, what is the number of subscribers, global subscribers increasing year after year, right? You can, these are the methods which you have already seen. So you can just, I've introduced a method called as a fill underscore between. So this fill underscore between, it will shade the area under the line, like between the line and the y-axis, say y equal to 0. So, and alpha is 0.15, which makes it very transparent, just a hint of color. Like this technique makes the growth feel much substantial, and visually you can see the area under the curve. So this is how you can use the fill underscore between method. And plt.annotate a method is mainly used to make out annotations. Like here I wanted an arrow with a return as COVID surge with plus 37 million subscribers. So I can make it out with an arrow style keyword calling out the dict function. So you can just execute this real world example, and you can see how your output is. And now let us see like what are the common mistakes that you have to avoid while you make out the plot. So the truncated y-axis on the bar chart, this is a common error. So say that an example that we can take as a bar chart compromising of two companies, a revenue of say 100 million and a revenue of 105 million. So if you start the y-axis at 95 million instead of 0 dollar, then you will probably get this error. So you can fix this out. Always you have to start the bar chart y-axis at 0. So that is very important. And the pie chart with 12 slices, like pie chart with 12 categories have slices of 3 to 10 degrees each. So human eye cannot distinguish between these angles. So it is better that you make out the slices. You can switch to a horizontal bar chart which is sorted by value rather than going out for a pie chart. And the other mistake that generally we make out is 3D bar chart for a 2D data. So softwares like Excel will let you make the 3D chart with one click. The results look like very impressive, but it is actually worse for for communication. So you can fix by flattening. You can flat your 2D chart and reserve your 3D only for the data that genuinely has got three numeric dimension. And too many series on a line chart is not advisable. You can use small multiples, one chart per series. So I'm leaving you the exercise 2.1 for the you to practice. So you can go through each and every scenario and make out the graph for this scenario. So after identifying the chart type, you can code it. You can use the exercise to equip yourself to work hard. And then once after you complete this, you can label all the charts for all the six scenarios. And next is about the polar chart. So polar chart is a specialized chart for the data which is inherently cyclic, or we can call it as angular. So mostly this polar chart is used for to represent the wind direction, like for meteorological data. So we can even call this polar plot to be as a meteorologist plot, like to make out the chart for specifying the wind direction. You can go ahead with this. So we generally use this for certain applications, and for to denote the time of day, like hours 0 to 24, you can form a natural circle. Then you could show when the event has happened during the day with the help of a polar chart. And you can use the method here to draw the polar chart. So here you can see like PLT dot subplot of projection. I'm giving it as polar, and you can plot a curve in the polar space. So before that, with lens space, here you can give like 0 comma 2 into NP. So 2 into NP dot sine of 4 into theta. Like you can make out the radius varies with angle, creating a flower like pattern. You can use this. So here I have used like 100 angles from a degree of 0 to 360. You can even vary with 4 into theta. Like you can just check it out. How does your plot look like? So this is how the polar chart mainly works. And for most of the data scientist work, you will have to use your polar plot very rarely, because but for the time of the day analysis, or for compass data, for any angular or acyclic, for the cyclic data, then you can go ahead. For acyclic data, there is no need for the polar chart. And for the filled area plot, and next is filled area plot. So this is a versatile tool that adds the emphasis and context to the line chart, something which is interesting than a line chart. Like you can have a shade for the line chart. It's like it shades the area between the two curves. Like if you provide one curve and no second curve, it shades between the curve and y is equal to 0, which will be the baseline. So it is mainly powerful, and it is very commonly used for weather forecasting, for temperature forecast, and for a certain uncertainty problems. So for model predictions with prediction interval, you can go ahead with this filled area plot. So here you can see the code np.lensspace of 0, 10, 100, and I have made out the sine curve, or sine curve plot, and I can give out the make out the sine curve, and we'll fill underscore between. It is a method that is used here. You can pass the argument x and y. X-axis valid. Y I've mentioned it as 0.2. The lower boundary is sine wave minus a 0.2, and here you can see it is the blue one is a sine wave, and I'm setting out the lower boundary as 0.2 and the upper boundary as 0.2. So lower boundary minus zero point 0.2, upper boundary as minus 0.2. So you can give out the color code, and the alpha here is given as 0.25, which is 25% opacity. And you can see the plot. You will get the output as you see here. It is a sine curve with the lower boundary and an upper boundary. So almost we have done all the chart which is under the Matplotlib library, and this is a quick reference that you can always have. So when you want to use for a trend over the period of time, you can go for line plot, for comparing the categories, bar chart, for distribution, histogram, for median and spread, it is going to be box plot, for density and summary. You can go ahead with a Violin plot for correlation, scatter plot for composition, pie or stack chart, and for matrices, heat map, for cyclic data polar, and for 3D data, you can go ahead with the surface or the scatter plot. So this is all about the entire plot library. We have seen almost 10 plus chart types, from line and bar and to Violin and till 3D, and we have seen how to code it and how to info from each and every plot. So here you can do a wonderful thing with this different charts, what that you have learned across this entire lecture. So the next module is going to cover about the subplots and the layouts, and you will learn how to build about the multi-panel figures, dashboards, and the complex grid layouts using the subplots. So nice. You can go ahead with the implementation. You can practice it. That will help you to learn a lot. Thank you.